In question 1, we have to solve the inequality 2x plus 1 is less than 3 into x minus 2. Now, whenever we have the modulus function involved, it is easiest if we just simply whole square both the sides. So whole squaring the left-hand side, we'll get 2x plus 1 whole squared. And this will become 3 into x minus 2. And we'll whole square this side as well. So 2x plus 1 whole squared, that will become 4x squared plus 4x plus 1. This is less than, and this will become 9 into x square minus 4x plus 4. Expanding the right-hand side, this will become 9x squared minus 36x plus 36. And the left-hand side remains as it is, 4x squared plus 4x plus 1. Now, to find the values of x, we can bring the left-hand side on the right-hand side. So 9x squared minus 4x squared, that will become 5x squared. This will become minus 36x minus 4x. And this will become plus 36 minus 1. Simplifying, we'll get 5x squared minus 39x plus 35. Now we can solve this through middle term breaking or factorization. And this is 40x. So minus 36 minus 4, that becomes minus 40x. So before we solve it through middle term breaking, we can just take first divide the whole equation by 5 to make it simpler for us. So this will become x squared minus 8x plus 7. Now, doing the middle term breaking over here, we get x squared minus, so this will become 7x minus x plus 7. And we can obviously solve it through a calculator as well, which will give us our answer quicker. So this will become x into x minus 7 minus 1 into x minus 7. So the two values of x we'll get is x minus 1, which is basically x equals to 1, and x minus 7 as greater than 0. Now, as this is greater than 0, to give the correct inequality sign, it is better if we just draw a graph. Now, one of the values is 7 and the other value is positive 1. Now, as we're talking about the graph, the values of x for which this is greater than 0, it means if we move forward from 7, the graph will be greater than 0. And if we go towards the left from x equals to 1, it will be greater than 0. So the final answer will be x is greater than 7 and x is less than 1. In question 2, we have to expand 1 upon cube root of 1 plus 6x up to and including the term in x cube. Now, to expand this expression, first we'll have to bring it in the numerator. So this will become 1 plus 6x. And as cube root is 1 upon 3, when we bring it in the numerator, the power will become negative 1 upon 3. Now we'll use the formula 1 plus nc1b power 1 plus nc2b power 2. And as you have to go up till x cube, so we'll have to also use nc3b power 3. Now we should know that nc1 is equals to n, and in this case, n is equals to negative 1 upon 3. nc2 is equals to n into n minus 1 upon 2 factorial, and nc3 will become n into n minus 1 into n minus 2 upon 3 factorial. Now, it is always better to find nc1, nc2, nc3 separately so that we don't make a mistake. Now, substituting the values of nc1, which is n, so in place of n, we can now write minus 1 upon 3 into b, which is 6x, plus nc2, that will become minus 1 upon 3 multiplied by minus 1 upon 3 minus 1, divided by 2 factorial, which is 2 multiplied by b squared, so that will become 6x whole squared. And finally, nc3, which is n into n minus 1. So we'll write it as minus 1 upon 3 into minus 1 upon 3 minus 1 into minus 1 upon 3 minus 2, divided by 3 factorial, which is equals to 6. So this will become 6. And we'll multiply it by b cube, which is 6x whole cube. Now, simplifying the expressions, we'll get, so this 3 and 6 will cancel out. So we'll get 1 minus 2x. Now, first simplifying the bracket, again, we should obviously use a calculator over here to avoid any mistakes. This will become minus 4 upon 3 divided by 2. And this will become 36x squared plus, so this will become minus 1 upon 3 into, and let's just erase this now over here. So this will become minus 1 upon 3 into minus 4 upon 3. And then minus 1 upon 3 minus 2, that becomes minus 7 upon 3 multiplied by 6x cubed. So that is 216x cubed. And then we'll divide it by 6 as 3 factorial is 6. So this 2 and 36 cancel out and become 18. So we'll get 1 minus 2x. The negatives over here will also cancel out. So this will become 4 times 18 divided by 9. So 4 times 18 is 72. 72 divided by 9, that becomes 8. So this will become plus 8x squared. And finally, substituting all of this in the calculator, we'll finally get minus. So minus minus becomes plus, and plus minus is minus. So this will become a negative sign over here. And as we substitute this in the calculator, we'll get this final answer as minus 112 upon 6 upon 3x cube for the final answer. So the final answer will be 1 minus 2x plus 8x squared minus 112 upon 3x cube. In question 3, it is given that x equals to ln of 1 minus y minus ln y. In part 1, we have to show that y equals to e power minus x upon 1 plus e power minus x. Now, as in the question, we have to make y the subject. So as the original expression is x equals to ln of 1 minus y minus ln y. As there is a negative sign, so we can write this as ln 1 minus y upon y. Now, as this is an ln function, so we can now simplify it as, and just for revision, we know that if it is ln of x is equals to y, we can write it as x is equals to e to the power y. So in this case, we can write this as e to the power x is equals to 1 minus y upon y. Now we have to make y the subject. So first we'll cross multiply. This will become y into e power x is equals to 1 minus y. Taking y on the left hand side, we'll get y into e power x plus y equals to 1. Taking y common, we'll get e power x plus 1 is equals to 1. And finally, we'll get y is equals to 1 upon e power x plus 1. However, as the expression said, e power minus x upon 1 plus e power minus x, we need e power minus x in the numerator. So what we can do is we can just multiply and divide by e power minus x in the numerator and the denominator. So the numerator will become e power minus x, and then e power x into e power minus x, that will become 1, and 1 into e power minus x, that will become plus e power minus x, which was the expression we needed, which was y is equals to e power minus x divided by 1 plus e power minus x. Now in part 2, we have to show that the integral of y dx with limits 1 and 0 is equals to ln of 2e upon e plus 1. So in place of y, we can use a substitution e power minus x upon 1 plus e power minus x with the limits 1 and 0. Now, to integrate this, we can see that we need the derivative of e power minus x in the numerator. So as the derivative of e power, so if we differentiate e power minus x, that becomes minus e power minus x. And as we need the derivative of the denominator, so which is 1 plus e power minus x, so that will be also equals to minus e power minus x. Now, in the first step, as we need a negative sign, so we'll put up a negative over here, and we'll also multiply this equation by minus 1. Now, integrating, we'll get this minus and ln of 1 plus e power minus x as the integral. Now, substituting the limits, which are x equals to 1 and x equals to 0. So substituting x equals to 1, we'll get minus ln of 1 plus e to the power minus 1. And we'll subtract it from the lower limit, which is 0. So this will become minus ln of 1 plus e to the power 0. Simplifying this, now first we can write this as 1 plus 1 upon e. As in the expression, we can see that we don't have a negative power with the exponential function. So now this will become plus ln of, and 1 plus 1 becomes 2. Now to make it easier, we can write this as ln of 2 minus ln of, and over here we can take the LCM. So this will become e plus 1 divided by e. Now when it is subtracting, we divide the function. So simplifying this, we'll get ln of 2, and this will divide by e plus 1 upon e. Simplifying this, we'll get 2 multiplied by e upon e plus 1, which is basically the final answer that we had to prove, which was ln of 2e upon e plus 1. For the parametric equations of a curve are x equals to ln cos theta and y equals to 3 theta minus tan theta. In part 1, we have to express dy dx in terms of tan theta. So to find dy dx, first we'll find dx by d theta. Now, as it is ln of cos theta, so when we're differentiating a ln function, we write the function which is with ln in the denominator and its derivative in the numerator. So the derivative of cos theta is minus sine theta. So dx by d theta will become minus sine theta upon cos theta. And now finding dy by d theta. So differentiating 3 theta, that will become 3. And when we differentiate tan theta, that will become sec squared theta. So this will become 3 minus sec squared theta. Now to find dy by dx, we'll divide dy d theta by dx d theta. So we'll get dy dx is equals to 3 minus sec squared theta upon minus sine theta upon cos theta. Now, as we have to express this in terms of tan theta, we know that sine upon cos is tan. So dy by dx can now be written as 3 minus sec squared theta divided by minus tan theta. And now we can write an identity in place of a sec squared theta. So we know that 1 plus tan squared is equals to sec squared. So this will become dy by dx is equals to 3 minus, and this will become 1 plus tan squared theta divided by minus tan theta. Simplifying, we'll get 3 minus 1, which is equals to 2. So that will become 2 minus tan squared theta divided by minus tan theta. Now, as we have a negative in the denominator, so we can just multiply by minus in the numerator and the denominator. So the final answer will become tan squared theta minus 2 divided by tan theta. In part 2, we have to find the exact y coordinate of the point on the curve at which the gradient of the normal is equal to 1. Now we know that dy by dx in the first part was given as, so dy by dx is equals to tan square minus 2 divided by tan theta. Now as the dy dx represents the gradient of the tangent, so and the gradient of the normal is equals to 1, so we can replace dy by dx by minus 1, as the gradient of the normal is a negative reciprocal. So this will become minus 1 is equals to tan square minus 2 upon tan theta. Cross multiplying, we'll get minus tan is equals to tan squared minus 2. Bringing the tan on the right hand side, we get tan squared plus tan minus 2 equals to 0. Now applying middle term breaking, we'll get tan squared plus 2 tan minus 2 equals to 0. This will become tan into tan plus 2 minus 1 into tan, and this will become, so we'll take 1 common over here, and this will become 1 into tan plus 2 equals to 0. So we'll get tan minus 1 and tan plus 2 is equals to 0. So this will become tan theta equals to 1, and tan theta will be is equals to minus 2. Now substituting these values in the calculator, so tan inverse of 1, that will become theta equals to pi upon 4. And taking tan inverse of minus 2, we'll get theta, that will be equals to 3 pi upon 4 minus 1. Now, as the limits for the value of theta is from 0 to 1 upon 2 pi, we'll only have these two values of theta as a final answer. In question 5, we have a semicircle with center O, radius R, and diameter AB. The point P on a circumference is such that the area of the minor segment of AP is equal to half the area of the minor segment on BP. It means that this area is basically half the area of this given area. So the angle AOP is x radians. We have to show that x satisfies the equation x equals to 1 upon 3 into pi plus sine x. Then the first step, we can just simply write what is given in the question, which is that the area of segment AP, so segment AP, that is equals to half the area of the segment BP. Now, first finding the area of the segment AP, we can first find the area of sector AOP and then subtract it from the area of triangle AOP. So for the area of segment AP. We'll first find the area of sector AOP and then subtract it from the triangle AOP. So the area of sector is given by the formula half r squared theta. So in this case, we have half into r squared and theta is x. And the area of triangle will be given by the formula half AB sine C. So this will become half, and the two lengths are r and r, so that will become r squared, and the angle is x, so this will become sine x. As half r squared is common, we can simplify it and write it as half r squared into x minus sine x. Now finding the area of segment BP, so we'll be finding it the same way as we did for the segment AP. So the area of segment BP, that will be is equals to the area of sector OBP. So we'll find the area of sector OBP minus the triangle OBP. Now in this case, as this angle is x, so this angle will become pi minus x, as the angle on a straight line is 180 degrees, or in radians it is pi. So this will become 1 upon 2 r squared into pi minus x, and then we'll subtract it from the area of the triangle, so that will become half into r squared into sine of pi minus x. Now we know that sine of x and sine of 180 minus x is the same. So it means that sine of pi minus x will be the same as sine of x. So we can simplify it and write it as, we can take half r squared common and write it as pi minus x minus, and this will become sine of x. Now using the original formula that we made, that the area of segment AP is equals to half the area of the segment BP. So area of segment AP is half r squared into x minus sine of x, and that is equals to half of the area of segment BP, which is half r squared into pi minus x. This is r squared, pi minus x minus sine of x. So half r squared and half r squared will cancel out on both the sides. You can cross multiply this 2, so this will become 2x minus sine x is equals to pi minus x minus sine x. And simplifying, as we have to make x the subject, so bringing x on this side, this will become 3x, and when you multiply by 2, so this should have been a 2 sine x over here. So this will become 2x minus 2 sine x. Now taking the minus 2 sine x on the other side, so minus sine x plus 2 sine x will become positive sine x, so we'll get plus sine x over here. And finally making x the subject, so we'll get x is equals to, dividing 3 on the right hand side, we'll get 1 upon 3 into pi plus sine of x. In part B, we have to verify the calculation that x lies between 1 and 1.5. Now, a simple way of doing this is we will first bring the right hand side on the left hand side. So we can first multiply 3 by x. This will become 3x is equals to pi plus sine x. And then bringing pi and sine x on the left hand side, we'll get 3x minus pi minus sine x equals to 0. Now, to show that the root x lies between 1 and 1.5, we have to show a change of sign. So first substituting x equals to 1, we'll get 3 into 1, which is 3 minus pi minus sine of 1. And substituting this in the calculator. So when we substitute this in the calculator, we get the value as minus 0.983. And when we substitute x equals to 1.5 into the equation, so this will become 3 into 1.5, which is 4.5 minus pi minus sine of 1.5. And the answer will be 0.3609 or 0.361. As we have shown a change of sign from negative to positive, it means that x lies between 1 and 1.5. In part 3, we have to use an iterative formula based on the equation part 1 to find the value of x correct to 3 decimal places. We have to give the result of each iteration to 5 decimal places. Now, as we already have the formula, which is x equals to 1 upon 3 into pi plus sine of x. And we know that the root lies between 1 and 1.5. So we can start off by taking the middle value, which is 1.25. Now substituting x in place of x, we'll substitute 1.25. So when we substitute 1.25, the first value we get is 1. So this will become x equals to 1.36352. And please make sure that when you're attempting this, you're writing your values to 5 decimal place in all the cases. So I'll just be using 3 or 4 decimal place just to explain. So in the next step, in place of x, now I will substitute x equals to 1.36352. So this will become 1.36352 over here. And when we substitute this in the calculator, we'll get 1.37339. Now substituting x equals to 1.37339, we'll get 1 upon 3 into pi plus 1.37339, and we'll get 1.37412. And then substituting x equals to 1.37412, we'll get, so this will become 1 upon 3 into pi plus sine of 1.37412. We'll get 1.37410. And when we substitute 1.37410, we'll still get the same answer. So the final answer will be, as we have to give it to 3 decimal place, so the final answer will become 1.374. In question 7, the complex numbers u and w are u minus 1 plus 7i and w is 3 plus 4i. In part 1, we have to show that the complex numbers u minus 2w and u upon w in the form x plus iota y. So in the first step, u minus 2w, that will become minus 1 plus 7 iota minus 2 times 3 plus 4 iota. Simplifying this, we'll get minus 1 minus 6, which will become minus 7, and plus 7 minus 8, that will become minus iota. So this is u minus w. For u upon w, we'll write first minus 1 plus 7 iota divided by 3 plus 4 iota. Now, as we have to remove the denominator, we can take the conjugate and multiply and divide with the numerator and the denominator. So this will become 3 minus 4 iota divided by 3 plus 4 iota. Simplifying the numerator, we'll get, so minus 1 times 3, that will be minus 3 plus 4 iota. 7 times 3 is 21, so that will become plus 21 iota. And 7 times 4 is 28, and iota square is minus 1. So that will become minus, and this will be a minus 28. Divided by, in the numerator, we'll have 3 times 3, and this is 3 minus 4 iota, not plus iota. So this will become 3 minus 4 iota. So we'll apply the identity, which is a plus b into a minus b is a squared minus b squared. So we'll get 9 minus, so 4 times 4 is 16, and iota times iota is minus 1. So this will become minus 16. So simplifying this, we'll get minus 3 plus 28, which is 25. 4 iota plus 21 is 25 iota, and this is dividing by 9 plus 16, which is 25. Simplifying this, we'll get 25 plus 25 divided by 25, which will become 1 plus iota. So this will be u upon w. In part 2, we have to prove that angle AOB is equals to 1 upon 4 pi, where O is the origin, A is represented by U, and B is represented by W. Now, to understand this, first we'll try and sketch this on an Argand diagram. So this is the origin. U has the coordinates minus 1 plus 7 iota, so we can put it over here. And this is U. And W has the coordinates 3 plus 4 iota, so this will be somewhere over here. And as it is talking about the angle AOB, so we know that U is A, W is B. So let's say this is point A, this is point B. We have to find this, we have to show that this angle is 1 upon 4 pi. Now, to find this angle, what we'll have to do is we'll have to find the complete argument of the complex number U, and then subtract it from the argument of the complex number B. So we can first write it as that angle AOB will be equals to the argument of U minus the argument of W, which can be written as argument of U upon W. Now, as we already have U upon W in a simplified form, which we did in the first step, which becomes 1 plus iota. So finding the argument of U upon W, we'll do argument, and we do tan inverse of, so we do tan inverse of Y upon X. So the y coordinate of u upon w is 1, and the x coordinate is also 1. So this will become So the argument will be tan inverse of 1 upon 1, which is equals to pi upon 4. In part 3, we have to state fully the geometrical relation between the line segments OB and CA. Now we know that O is the origin, so OB will be, and as the coordinates for B were, so B was 3 plus 4 iota, so OB will become 3 plus 4 iota, and finding CA, so CA will be equals to A minus C. A was presented by U, which was minus 1 plus 7 iota. So we'll write minus 1 plus 7 iota over here. And C is represented by U minus W, U minus 2W, which is minus 7 minus iota. So in this question, C was represented by U minus 2W, which is minus 7 minus iota. So we'll write minus 7 minus iota over here. Simplifying this, we'll get minus 1 plus 7 iota plus 7 plus iota. Simplifying this, we'll get minus 1 plus 7, which is 6. 7 iota plus iota is 8 iota. Now, once we have both OB and CA, we can see that they are in a particular ratio. So if we take 2 common from CA, we'll get 2 into 3 plus 4 iota, which means the first thing we can say is that OB and CA, they are parallel. And for the second mark, we'll have to give the ratio. So the ratio for OB is to CA will be 1:2. Or we can also write it as CA is basically twice of OB. Both answers will be marked correct. In question 8, by first expanding 2 sine into x minus 30, we have to express 2 sine x minus 30 minus cos x in the form r sine of x minus alpha. So we know that if it is sine of a minus b, it is given as, so I'll write it in short form, it will become sine a cos b minus cos a sine b. So in this case, we have sine of x minus 30. So this will become sine of 30 cos x minus cos of x sine 30. Now multiplying this by 2, so we know that, okay, so this would have been sine of x cos 30. This will become sine of x cos 30. And now multiplying this by 2, we know that cos 30 is root 3 upon 2. So this will become sine x root 3 upon 2 minus cos x, and sine 30 is half. So this will become half cos x minus cos x. So 2 times root 3 upon 2. So that will become root 3 sine of x. 2 times half will become 1. So this will become minus cos x minus cos x. And simplifying this, we'll get root 3 sine of x minus 2 cos of x. Now, as we have to express this in the form r sine of x minus alpha, if it is given in the form sine plus cos, so to find r, we do square root of the coefficient of sine and cos. So this will become root 3 whole squared plus minus 2 root minus 2 whole squared. Simplifying this, we'll get root 3 plus 4, so that will become root 7. And to find alpha, we'll have to do tan inverse of, so alpha will be equal to tan inverse of 2 divided by root 3. Substituting this in the calculator, we'll get 49.106. And we can simplify it to write it as 49.11. So alpha will be equals to 49.11. In part 2, we have to solve the equation 2 sine of x minus 30 minus cos x equals to 1. Now, in place of 2 sine of x minus 30 minus cos x, we can substitute the form r sine of x minus alpha. We already have the value of r, which is root 7 into sine of x minus, and alpha is 49.11 equals to 1. Now, taking root 7 on the right hand side, we'll get sine of x minus 49.11 is equals to 1 upon root 7. And finally, x minus 49.11 will be equal to sine inverse of 1 upon root 7. So we'll get the basic angle, which will be 22.21. So we'll get x minus 49.11 is equals to the basic angle, which is 22.21. Now we know that sine is positive in the first and the second quadrant. So we'll have to make the basic angle 22.21 in the first and the second quadrant. So we'll get two values of x in this case, which will be, so x will be x minus 49. Let's change the color over here. So let's use the blue color. So x minus 49.11 will be equals to 22.21, and we'll subtract 180 minus 22.21. So that will become 157.79. Now we'll add 49.11 to both the answers. So this will become 22.21 plus 49.21, that will become 71.3. And when we add 157.79, so 157.79 and 49.11, that will become 206.9. But as the value of x can only be from 0 till 180, so the final value of x will be x equals to 71.3 degrees. In question 9, part 1, we have to first express 1 upon x into 2x plus 3 in partial fractions. So to express this into partial fractions, we'll first write it as, so this can be written as a upon x plus b upon 2x plus 3. Now taking the LCM, so a will multiply by 2x plus 3 and b will multiply by x. And it is equal to the numerator on the left hand side, which is equals to 1. Now, a simple way of finding the value of a and b is we can make either of the terms 0. So initially taking x equals to 0, we'll get, so the bx term will become 0. We'll get 1 is equals to a into 0 plus 3, which is 3. So a will be is equals to 1 upon 3. To find the value of b, we can take the value of x as, well, I think it will become minus 3 upon 2. So if we take x equals to minus 3 upon 2, so this will be 2 times minus 3 by 2 plus 3 plus b into minus 3 by 2. So 2 and 2 will cancel, minus 3 plus 3 will become a 0. A simple way is I just took 2x plus 3 and put it equals to 0, as we have to make the a term 0 now. So x was equals to minus 3 by 2. So this will become 1 is equals to, this will become 0, minus 3 plus 3 is 0, minus, so this will become 3b upon 2. Cross multiplying, we'll get 2 times 1, so that will become 2 is equals to minus 3b, and b will be is equals to minus 2 upon 3. So the final answer will be, as a is 1 upon 3, so this will become 1 upon 3x minus 2 upon 3 and into 2x plus 3. In part 2, we have a differential equation, which is x into 2x plus 3 into dy by dx is equals to y. And it is given that when y equals to 1, x equals to 1, we have to solve the differential equation and then calculate the value of y when x equals to 9. Now, to solve a differential equation, first you'll have to bring the x terms with dx and the y terms with dy. So bringing y on the left-hand side, we'll get dy upon y. And taking dx on the right-hand side, that will become dx. And x and 2x plus 3 will come in the new denominator. Now, as we have already broken this up into the partial fraction, the answer was 1 upon 3x minus 2 upon 3 into, so that was 2 upon 3 into 2x plus 3 dx, and this was dy upon y. So this was dy upon y. Now, to solve the differential equation, we'll integrate both the sides. Now, integrating 1 upon y, that will become ln of y. Integrating 1 upon 3x, so we can leave 1 upon 3, and integrating 1 upon x, that becomes ln of x. Leaving 2 upon 3 as the coefficient, integrating 1 upon 2x plus 3, will get ln of 2x plus 3. And then we also divide with the derivative of 2x plus 3, which is 2. And we add a constant. So 2 and 2 will cancel out, and we'll have ln of y is equals to 1 upon 3 ln x minus 1 upon 3 ln of 2x plus 3 plus c. Now, to find the value of c, we know it's given that when y is 1, x equals to 1. So this will become ln of 1 is equals to 1 upon 3 ln of 1 minus 1 upon 3, and ln of 2 plus 3, that will become 5 plus c. ln 1 is 0. So both of these terms will cancel out. and minus 1 upon 3 ln 5 will go on the left hand side. So the value of c will become 1 upon 3 ln of 5. Now we have the value of c. So this is ln of y equals to 1 upon 3 ln of x minus 1 upon 3 ln of 2x plus 3 plus 1 upon 3 ln of 5. Now we have to find the value of y when x equals to 9. So in the first step, we can just simply substitute as 1 upon 3 is common. So we can write it as 1 upon 3 into ln of 9 minus ln of, so 2 times 9 is 18 plus 3 is 21 plus ln of 5. Now substituting this in the calculator. So when you substitute this in the calculator, we'll get ln 9 minus ln of 21 plus ln of 5, which is 0.762, and then dividing this answer by 3. So we'll get 0.254. So ln of y is equals to 0.254. And then to find the value of y, so y will be equals to e to the power 0.254. Substituting this in the calculator, we'll get e to the power 0.254, which is equals to 1.289. So y will be equals to 1.289. And as we have to give our answer to 3 significant figures, so the final answer will become y equals to 1.29. In question 10, the diagram shows the curve y equals to sine x cos square 2x and its maximum point M. In part 1, using the substitution u equals to cos x, we have to find the exact area of the shaded region bounded by the curve and the x-axis. Now, to find the area of the shaded region, we'll have to integrate the given equation, which is sine x cos squared 2x dx, and the limits are pi upon 4 and 0. Now, as you have to use a substitution, so the first step is always to first write down the substitution, which is u equals to cos x, and also write the derivative of the substitution, which will become du by dx, which will be equals to negative sine x. So when we are substituting in place of dx, so dx will be is equals to minus du upon sine x. So substituting in place of dx, so the first thing to remember when we are doing substitution is, before we do any substitution, in place of dx, first we'll make the substitution. So this will become sine x cos squared 2x, and we'll write minus du upon sine x. So sine x and sine x will cancel out. This will become pi upon 4 and 0. Now we are left with cos squared 2x, and as a substitution is u equals to cos x, we know that the identity for cos 2x is, so cos 2x is equals to 2 cos squared minus 1. And now in place of cos squared, we can put u squared. So this will become 2u squared minus 1. So this can be written as 2u squared minus 1. And as it is a whole square, so we'll put a whole square over here, minus du. And as the function is now in terms of u, so we'll have to also change the limits. Now, as u was equals to cos x, so in place of x, when we put pi upon 4, so this will become u is equals to cos of pi upon 4, which is equals to 1 upon root 2. And when we take cos of 0, which will be equals to 1, so the limits will be 1 and 1 upon root 2. Now, before integrating, we can first expand this expression. So when we expand this, this will become, so 2u square whole square, that will become 4u to the power 4 minus 4u squared minus 1. And now integrating 4u power 4, we'll get 4 upon 5u to the power 5 minus, so integrating u squared, that will become 4 upon 3u to the power 3 minus integrating 1, we get u. And now substituting the limits, which was 1 and 1 upon root 2, we can leave the negative sign outside as it is. Now substituting x equals to 1, we will get 4 upon 5 minus 4 upon 3 minus 1. And so this will be a plus 1 over here. When we whole squared, a squared minus 2ab plus b squared, so this will become a plus 1. And then we substitute the lower limit, which is 1 upon root 2. So this will become minus 4 upon 5 into u to the power 5. So this will become 1 upon root 2 to the power 5. And I have to write this so that we only have a single page for this answer. So we have to make sure that all our working fits inside this page. So this will become 4 upon 5 into 1 upon root 2 to the power 5, then 4 upon 3 into 1 upon root 2 to the power 3 plus 1 upon root 2. So 4 upon 5 minus 4 upon 3 plus 1, when we take the LCM and simplify this will become, so the LCM will be 15, this will multiply by 3, this will multiply by 3, this will multiply by 5, this will multiply by 5, and this will multiply by 15, so this will multiply by 15. So we'll get 12 minus 20, which is minus 8 plus 15, which is 7, minus, so 1 upon root 2 to the power 5, that will become 1 upon 4 root 2, 1 upon root 2 whole cube, that becomes 1 upon 2 root 2, and 1 upon root 2 will remain as it is. So as we have to give the answer in an exact form as it is given in the, we have to find the exact area, which means we cannot give our answer in terms of decimal. Else we could have just substituted this in the calculator and found the exact value in terms of decimal. So now simplifying over here, now we have this 4 and 4 will cancel out, this 2 will cancel out with 4. Now, as we have a root in the denominator, we can multiply and divide by root 2 in the numerator and the denominator. So this will become root 2 upon root, and in the denominator, when we multiply by root 2, so that will become 2 times 5, which is 10, minus, so multiplying by root 2 over here, this will become 2 root 2 upon, and this will be 3 times 2, as root 2 times root 2 becomes 2. So 3 times 2 is 6 plus, and this will become root 2 upon 2. Now taking the LCM over here, we'll get 7 upon 15 minus, so the LCM of 10, 6 and 2, that is 30. So this will multiply by 3. So this will become 3 root 2 minus, multiplying this by 5, this becomes 10 root 2, and multiplying this by 15, that becomes 15 root 2. So 3 minus 10 is minus 7 plus 15 is 8. So we'll have it, the answer will become 7 upon 15 minus 8 root 2 upon 30, and we can simplify it and write it as 7 upon 15 minus 4 root 2 upon 15. Now we can bring in the negative sign that we left out in the beginning, which was over here with the negative du, or we can leave our answer in this form, as both of the answers represent the area. So even if we leave our answer in this form, this will be the correct answer for the area of the shaded region. In part 2, we have to find the x coordinate of M, giving our answer correct to 2 decimal place. Now we know that M is the maximum point, which means first we'll have to find the dy by dx, as y was given as sine x, and it was sine x cos squared of 2x. So as they're multiplying, we'll have to use the product rule. We know that dy by dx will be is equals to v u dash plus u v dash. So taking u is equals to sine x, u dash, or the derivative of u, will become cos x, and v is cos squared 2x. So we can write it as cos 2x whole squared. So finding the derivative, 2 will multiply over here. This will become 2 into cos 2x, and the derivative of cos 2x will become minus 2 sine 2x. The derivative of cos is sine, and the derivative of 2x is 2. So this will be minus 2 up over here. So simplifying, we'll get 2 times 2, which is 4. So minus 4 cos 2x sine 2x. So once we have the value of u dash and v dash, now we can just substitute these values in the calculator. This will become, so v u dash will become, so v is cos squared 2x. So this will become cos squared of 2x multiplied by cos of x. And as it is a maximum point, so now we can put dy dx as equals to 0. Plus, and uv dash will become sine x into minus 4 cos 2x sine x. So this will be sine x into minus 4 cos 2x sine x. We can take the this term sine x into minus 4 cos 2x sine x on the left hand side. So this will become 4 sine x cos x, and this is 4 sine x, and this was a sine 2x over here. So this will be sine 2x. So 4 sine x, and this is sine 2x cos 2x. is equals to cos squared of 2x cos x. Now we can cancel out cos squared 2x with cos 2x with cos squared 2x. Now in place of sine 2x, we can substitute. So sine 2x is the same as 2 sin x cos x. And as we have to solve the equation, so we can bring our equation in terms of either sin x or either cos x. And in place of cos 2x, we can write 2 cos squared minus 1 into cos of x. So cos of x will cancel out with the cos of x on the left hand side. We'll be left with 8 sine squared of x is equals to 2 cos squared minus 1. Now, if you want to bring it in terms of cos squared, so in place of sine squared, we can write 1 minus cos squared is equals to 2 cos squared minus 1. Opening the bracket, we'll get 8 minus 8 cos squared is equals to 2 cos squared minus 1. Taking 8 cos squared on the right hand side, this will become 10 cos squared. Taking minus 1 on the left hand side, this will become 9. So cos squared of x will be is equals to 9 upon 10. So now we just have to square root 9 upon 10 and then take cos inverse. So substituting this value in the calculator, we'll get, okay, so cos inverse of square root of 9 upon 10. So that becomes, okay, so just a moment. So that will become 9 over 10. And as we have to make sure that our answer is in, as our answer is in radians, we'll make sure that calculator is in radian mode. So this will become 0.3217. So the value of x will be 0.3217. Rounding off our answer off to 3 significant figures, our final answer will become 0.322 for the value of x. And as we had just had to find the x coordinate of m, so we'll just leave our final answer as 0.322.